Hey, boys and girls, gonna make a video today. We're gonna be starting our division unit. I wanted to show you kind of what that means or kind of what that looks like. So pretend each of those little circles is something like a cube or something you could actually physically manipulate. Let's say it was PE class or bitty basketball or something, and there were 19 kids. It was a little divided there. I know that two little dots are hard to see. It looks like subtraction. There are actually two dots there. It's divided by. So that is 19 divided by 4. Let's say there was 19 kids and they wanted to make 4 teams, play 2 different games of basketball. And you're trying to figure out like how many kids would be on each team. Again, there's a team with black shirts, a team with red shirts, a team with green jerseys, and a team with blue jerseys. And we're going to kind of spread these 19 out. I'll just check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So each team is going to get one player. So again, there's the first player on each team. Okay. So you see how, again, we took one person or one student, we put them on each team. And then the blue team gets a second player. It looks like eyes there. And the green team gets a second player. The red team gets a second player. And the black team gets a second player. Okay, with dividing, things have to be fair or equal. Okay, so you notice again, each team has 2 players right now. Okay, and then I'll start back over here. The black team gets a third player. The red team gets a third player. The green team gets a third player. And the blue team gets a third player. Yeah, I might not have put enough for one team. We'll see. Okay, and then I'll go back to that again. Again, black team gets a fourth player. Red team gets a fourth player. Green team gets a fourth player. And the blue team gets a fourth player. I did that right. Okay, you'll notice again that there's not another blue one there. And so if I was doing the actual division out, each team got 4 players. Okay, that's kind of every single team got 4 players. And then what happens with these other kids over here? Okay, we kind of call that a remainder. I do have enough to put a 5th player on the black team, the red team, and the green team. But you'll notice I would have needed one more person for each team to have 5 players. We weren't quite able to do that. And I can either leave that like that and have just that team play with one less kid than all the other teams, or again, we can try to figure something else out. All right, so one way to answer this 19 divided by 4 is we would say the answer is 4 remainder 3. Each team got a fair amount of 4 whole players, okay, but we would have needed 20 for them to each have 5 players. Again, that's just kind of multiplication and division, but backwards. And as we get more into this, we'll kind of use this kind of earlier stuff early on, or you could just make your little circles and figure that out first. But eventually we'll get into the part where it's 19 divided by 4. You try to see, well, how many can I make? And I know the closest I can get is 4 times 4. So that 4 goes up top. 4 times 4 is 16. That's how many we use down here. And then we subtract, and that's our 3 that's left over. That's kind of the basic version of division. Okay, it's kind of different things I'm going to do with it that I will show you as well. This is just kind of one step. Again, remember where those 19 circles all were at the beginning? I was able to fairly or equally make it so there was 4 students on each team, and there was an additional 3 players that were left over. And I'll show you kind of a different example or something else different that we would sometimes do. Next part is called interpreting a remainder. So I'm going to actually show you 2 different word problems with basically the same numbers. So the first one has the red underlines, then I'm going to pause it and I'm going to reword the question in blue and kind of show you how that changed. So the first one I think about is like a field trip, right? So we're going on a field trip, and the people that work at wherever we're going, okay, let's say if we were going to the Museum of Science or something, they say you can't have groups bigger than 6. Okay, so we would know, okay, we have to have an adult for every group of 6 students. And we have 28 students going, right? So I'll read the question. There are 28 students going on a field trip. The groups for the field trip can't have more than 6 students in them. So that's just a rule at, let's say, wherever we're going, the Museum of Science, they say okay, groups of kids can't be more than 6 kids for 1 adult needed. It's kind of how many chaperones or how many adults do we need to come on the field trip. So when I'm doing 28 divided by 6, I'm trying to think, like, what's the closest I can get with 6? And I'm sitting there thinking and counting. One chaperone would take care of 6 kids. 2 would take care of 12. 3 would take care of 18. And 4 would take care of 24. And 5 would take care of 30. So as I'm kind of going through that, right? Here's one group. That's 2 groups, 3 groups, 4 groups, and 5 groups. So it's a little harder to kind of think of math-wise. Okay? 5 groups. I don't have 30 kids. And most groups I would have here, thinking about it that way, would be 24. I have 4 groups that are filled. And here's the problem. 4 times 6 is 24. But I have 28 kids that need to go on the field trip. So there would be 4 kids left over. So I get to say, sorry, you 4 kids don't go. So this is where interpreting a remainder can be difficult. It can be a little bit confusing. I have to say this other group of 4 is going to need a 5th chaperone. So in this case, in order for all the kids to go, even though each group didn't have exactly 6 kids in it, we actually had less. That's okay. We would still need, though, a 5th person. Okay, if that makes sense, right? If I do 28 divided by 4, my answer is just 4. Each group got 4 kids. Or sorry, each group of 6, there was 4 full groups of 6 would be the way to word that properly. Okay, but then there's 4 kids left over. I can't just call it 4 remainder 4. Was kind of our actual answer here. Okay? Again, I can't just tell these are people that want to go on a field trip. Kids, right? Like 10-year-old. I can't just be like, oh, sorry, you 4 don't get to go because we ran out of chaperones. Right? We only have enough for 4 groups. In this case, you say, nope, this remainder gets kind of bumped up 1. Say, don't worry about it. We're just going to make a 5th group, even if it doesn't have 6 whole kids in it. So that's one way to interpret a remainder. And again, I'll pause it. I'll change some things around and show you the other way. Now we have the same exact numbers, the same exact division, the same exact everything else, except it's going to be a different word problem. So now think about making apple pies, which I know absolutely nothing about, but that's not really the point here. Okay? I don't know why that won't slide up. Okay, so there are 28 apples that are going to be used for the apple pies. So again, instead of 28 kids that want to go on a field trip, this is now 28 apples that we bought, that we're going to use to make apple pies. Each pie, shouldn't have an S there, that's why I teach math and not ELA apparently. Each pie needs to have 6 apples in them. Okay, so again, same division here. It's still the 6 is 1 pie, 12 is 2 pies, 18 is 3 pies, 24 is 4 pies, and 30 is 5 pies. So that part has not really changed. It's 1 pie, 2 pie, 3 pies, 4 pies, and a 5th pie. Okay. So now, again, if it takes 6 apples to make an entire pie, well, I can only make 4 of them. So this is kind of the difference between interpreting that remainder. We can only make here 4 pies. The other one, we only have 4 apples left, that kind of 4 remainder 4, right? According to my recipe that I'm pretending to use, because I don't know how to make anything like apple pie, right? I need 6 apples to make another pie, but I only have 4. So you see how when it was kids that wanted to go on a field trip, that remainder of 4 means I needed a 5th group? If I need 6 apples, though, to make that 5th pie, I don't have 6 apples. I only have 4. So I can only make 4 apple pies, 4 full apple pies. Okay, so that'd be the difference here. Here, even though it's the same exact question, both were really 28 divided by 6. But in one of them, the answer was we needed 5 chaperones. Again, I can't, unless you're like, hey, sorry, you 4 kids, you don't get to go. But that's kind of mean. Here, though, I can say I have 4 apples left over. I can only make 4 full pies for Thanksgiving or for whatever it happens to be. Okay, so that would be the difference there. So watch out for that when you're working on these. If you have any questions, kind of let one of us know. Again, it was the same exact question. There are 28. At first, it was students that wanted to go on a field trip, and each group couldn't have more than 6 kids in it. Okay, so 28 divided by 4 was 4, remainder 4. I'm sorry, 28 divided by 6, was 4, remainder 4. Here, though, those 4 kids means they need a 5th group. Here, those 4 extra apples, same exact problem. There are now 28 apples that are going to be used for the pies. Each pie needs to have 6 apples in them, or in it. Okay? Again, those 4 extra ones say, oh, sorry, we can't make another one. So we can only do 4 whole groups. Hope that makes a little sense. Hopefully you're able to work on that. It's also going to ask you some questions like, are there any leftover pieces? Yes. Okay? How many whole, groups, or how many whole sets could you make? Oh, I could make, here you would say I could make 4 whole sets with 4 left over. Do I need a 5th one? Like, yes, might be the answer to some of these questions. And I'll show you another one of those then in a second that lines up more with what they're going to have you. Okay, there's a question similar to this on your assignment. So I just wanted to kind of go over it and show you kind of the different things that they're going to ask you to do. Okay, it's not 4 feet in yours, it's 3 feet, and I'll kind of show you that, but you need to know here that 1 foot equals 12 inches, and we'll learn that later in the year. We do conversions, and I put a little word problem here. Mrs. Latanzio has 4 feet of ribbon. The bows she's designing use 5 inches of ribbon each. Okay, so every time she uses 5 inches of ribbon, she can make 1 bow. How many bows can she make? That's kind of our primary question, or our number one question that we're trying to figure out. So a couple things we have to do first here. First, we have to convert our feet to inches. And I said convert feet at the same time. If 1 foot is 12 inches, how much is 4 feet? So 1 foot is 12 inches of ribbon. If we had 2 feet, that means she would have 24 inches. That's your 3 feet, which again, you're going to need to use this on your assignment, would be 36 inches. That's just times 12. 1 times 12 is 12. Anything times 1. 2 times 12, you double it. 12 plus 12, 24. 3 feet, 24 plus 12 more, 36. And then the one we're looking for here, 4 feet is 48 inches. Okay, so we have 48 inches of ribbon. We're going to divide that. Those dots are kind of hard to see. We're going to divide that by 5. How many whole bows can she make? Okay, we're counting by 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Again, I don't quite have 50. So the most I can make is 9, and then there would still be a little bit left over. So they might ask you a couple different questions. And I'll just pause it and I'll just check and see what the question is, just to make sure you guys are on the same page. Might be kind of hard to see, but I'll read them. I was trying to squeeze that all in. So the first question might be something like, how many bows can she make using 4 feet of ribbon? Okay, and the answer to the first question would be 9. That 9 that we just figured out. Okay, 9 times 5, the closest we can get is 45. Okay, that was kind of the closest that we could get to that. So that would be one question they might ask you, like, how many actual bows can she make? She can make 9 full bows. Sometimes, I don't remember if this one had it or not, but other questions did. They might ask a question like, was there any ribbon left over? And it's just kind of a yes or no. Here our answer would be yes. You either kind of click a little dot or something, like they might have dots next to them, and you would click on the dot next to yes. Then how many inches of ribbon were left over? And that's what I was getting to over here. 48 minus 45 would be 3. So again, that's all they would want for an answer. They would just want you to write 3. Okay? And that's kind of what your assignment is going to be for today.